You're listening to Brain Lenses. I'm Colin Wright. A recent study looking into how sleep disruption might mess with a rat's ability to store long-term memories found that a signal linked to memory storage is disrupted when rats don't get sufficient sleep. The disrupted signal is called the sharp wave ripple and involves a huge number of neurons all firing in synchrony, which then causes another group of neurons to do the same, which causes another group to do the same, and on and on. This ripple of firings occurs in the hippocampus, which plays a vital role in memory formation, and it's thought that this neuron firing cascade is what allows the hippocampus to communicate with the neocortex, which is where long-term memories are ultimately stored. If a rat returns to a part of their cage where a memory was previously stored, this cascade effect is sometimes triggered, those groups of neurons firing again, replaying the brain activity from that previous experience, which researchers believe represents the evocation, remembering, of stored long-term memories. In a previous study, researchers interrupted this cascade process to see if doing so would mess with a mouse's performance on memory tests related to information they were ostensibly in the process of storing when interrupted. And those interruptions did indeed seem to negatively impact their subjects' test performance. This new study asked the same question, but of sharp wave ripples that arise during sleep. These sleep ripples are thought to be part of how our brains consolidate memories over the long term, reinforcing those earlier cascades of neuron firings while our bodies and brains rest. Researchers tracked these processes in sleeping rats, interrupting their sleep when they detected these cascades to see if that would impact the subject's memories. They found that rats who were regularly awoken, their sleep cycles consistently disrupted, still had consistent levels of sharp wave ripple activity, but the activity was weak and disorganized compared to that of the control group rats who slept normally. The sleep-deprived rats returned to their normal neural patterns after a few days of non-interrupted sleep, but their performance of the patterns that were disrupted, those that their brains were never able to lock in with nighttime revisitation, were never quite as strong as in the control group. So what this suggests is that if we want to benefit from strong memories, it's important that we sleep well and consistently, in addition to thinking uninterrupted thoughts right after we learn or experience something we would like to recall long term. It also hints that periods of disruption of both sleep and wakeful varieties could impede our ability to accurately and clearly recall things that happened just before and during those periods, which could thus mess with our perception of entire portions of our lives, like, for instance, periods in which we spend a lot of time in chaotic workplaces, during which we're drinking a lot and consequently not getting great sleep, or when our sleep and wakeful cycles are disrupted because we just had a baby, or are suffering from some other source of consistent stress. I'm able to present Brain Lenses in both its written and audio formats ad-free because of support from listeners like you. If you're enjoying what I'm doing here, consider becoming a paid supporter for the cost of a cup of coffee each month at brainlenses.com.